So, hello everybody. My name is Jaan Praks, and I'm going to be a host for the last session of the conference. And our session is about software-defined satellites. I have two visionaries here with me, and these visionaries are on a bit different fields. First, I have here Coggin, who is with No Systems. Right. And he has a track record of almost 20 years of working with cyber technology, cyber threats, security, satellite, space technology, networks, attack vectors, protection, you name it. And he has been very visionary and first, or let's say, visionary in this field, going around also in the conferences, giving excellent talks about what is actually happening with the cyber field of satellites. So, and the second panelist here is Erik Kulu. Erik has started with S-Cube, the first serious movement of space technology in Estonia, has been making his way through Clyde Space and Kepler and some other companies and endeavors. And mostly he's known because he has been assembled with the world-famous databases for new space technology, small satellites, factories in space. So if you are looking for statistics or any kind of information in the web about where we are going, then Erik is behind this data, and he has also a wonderful insight what is actually happening in the world. All right. But today, we need to talk about software-defined satellites. And if I start with Erik, so Erik, you were actually writing in the abstract of this year's proposal that last year you were asking people and they were not able to tell what is a software-defined satellite. So can you elaborate?
Sure, happy to. If you Google software-defined satellite, then the most common response is about primarily a geostationary communication satellite where you can then change the frequency bands, you can change the coverage area, and so on. But I think the term should be wider. I think I would call it just reprogrammable satellites, which are quite old already. Even in SQ1, we did update basically most subsystems.
So you mean like a software-defined satellite is something which can be reconfigured by software?
Even reprogrammed, yes, to do new tasks.
Mm-hmm. Okay. Paul, what is your take? If you hear a term called, like somebody says software-defined satellite, what are your thoughts?
Very similar to Erik, the concept of being able to reconfigure the personality of the satellite, like Erik mentioned, like software-defined radios and changing the configuration. But I guess more specifically what I've been thinking the last couple of years, and I've doing a lot of research, I see that there's others in the industry that are headed in this direction, not only with software-defined radios being able to be reconfigured, which has been proven with the issues that are going on in Ukraine right now, where SpaceX has been reprogramming their satellite to use different frequencies on demand based on electronic warfare. But also, there's a great deal of research of using containers, software containers, where the underlying operating system for the satellite, instead of what it used to be like over 20-something operating systems that might be used, that might be proprietary or very specialized, like might be VxWorks or some other of a proprietary operating system. Now most of the satellites are going to Linux, but not only with Linux, but using Docker containers, Kubernetes, and since we can, like Erik said, saying you can do reconfiguration, if we're going to Kubernetes and Docker containers on satellites, why can we not go and change containers? Maybe the satellite, the mission is over, and we can, if the hardware supports it, we could change the personality by just changing the container.
But as I said yesterday, we are limited by like the hardware, right?
That's right.
So
that's right.
There is a limit to what we can do only with software, and like whether it's worth doing it in space at all. But yeah, we can't make.
Which brings me to the next question, actually. Can you map a bit what kind of features, what kind of properties of a satellite can be already now reconfigured by software? Is there like, can we have payloads which can be reconfigured, or do we have just the orbit control? Erik, maybe you have some ideas.
As I mentioned, communications, that's easiest. Mostly the radios are software defined, so everything, a radio communication.
Yeah, so you can reprogram your waveform, you can reprogram your frequency band, you can reprogram your bandwidth.
And that might change the task, right? So we can now connect directly to phones from Iridium satellites, or soon we'll be able to, we might do commercial GNSS from communication satellites.
Yeah, so you can reprogram, for example, satellite to be maybe navigation satellite instead of the communication satellite, or even radar. So radio technology goes far. What else do we have in satellites which can be reconfigured?
Well, I was, as you was asking the question, I was thinking about maybe image processing applications that could be changed over to some other Earth observation application. Because like Erik made a very good point, you're going to be limited by the hardware. You can only put so much hardware into a spacecraft. You're going to be limited by budget, power, things. But it's going to be really important to have a vision in that initial systems engineering to look out as far as you can of how the satellite might be able to evolve. Maybe you change from some kind of mapping image processing application to some of like wildfire observation. If maybe you can change those type of personalities if it's common. But I like what Erik brought up with communications as well. Especially we're seeing so much happening now with communications. We were talking earlier like Internet of Things, 5G, 6G. It's happening. Maybe if the satellite has the hardware functionality, you can reconfigure the software-defined radio to support new communications capabilities.
Yeah, I think there is also like hyperspectral, first hyperspectral technologies coming out which has totally reprogrammable like spectral bands. So you can measure anything like in the visual range or the near infrared or even infrared. So you just like, you can reconfigure it by software to do a totally different tasks and like measure different profiles. Is there any like mechanical parts which we could maybe think which can be reconfigured, or should there be? Maybe not going yet there, but is there anything which we can reconfigure in the satellite so that it makes it software defined?
I mean, it's not very common, but robotic arms. So there are several on the ISS. They are constantly being experimented with different software. Moon rovers, Mars rovers, I think we have seen a lot of software updates there also.
So that means also the robotics going into this direction, that we are getting more and more satellites which have more and more parameters which can be reconfigured by a software. All right.
And it's also about optimization, right? So we might launch a software, but then we give it more features. We try to improve the processing time, more efficient algorithms.
So you think like satellites are going to be like Android phones? You upload the new software and you have almost like a new phone?
Limited by hardware.
All right. Okay, but software is always vulnerable also for different kind of attacks. So probably our nowadays satellites are not the first ones which are at least partly defined by software. So do we have any good examples from the history where the software of the satellite has been the vulnerability and it has been like getting some attacks or something has been going wrong with the software? What kind of threats are there for a software based on history?
What's predominantly been documented is attacks where an adversary has gone through the ground station, and from the ground station, with compromising trust relationships in the ground station, they've been able to pivot from the ground station to the satellite, which makes perfect sense. But there are cases speculated that an adversary may have been able to bring up a rogue, unauthorized ground station and through RF communication, been able to access a satellite and take control. There's a number of events that happened in the early 2000s timeframe where that was happening, where satellites had been temporarily taken control of. And what I've read in the research, it doesn't go into a lot of great detail specifics of what actually happened and how they recovered access and control of the satellite. But what I always speculate in my mind is probably fallback scripts, some kind of watchdog timers, kick the adversaries off of the satellite. But there have been a number of satellites that have been accessed, weather satellites, Earth observation satellites, some space research satellites.
Can you name any actual occasions
like the Terra satellite and the Rosat satellite? There was a collaboration between the U.S. and Germany, and the Rosat satellite was accessed. It was speculated that it was a ground station in Norway was compromised, and the satellite was turned back up towards the sun and disabled. And the satellite got disabled. There's a whole lot of going back and forth. That there was no forensics proof that the ground station was actually hacked, according to the operators of the ground station. So if that is true, then someone was possibly able to bring up an unauthorized ground station and access the satellite directly. But someone got access to the Rosat satellite. So it's either through
the 1998, something like 2000.
I think it's in the early 2000s.
Okay, yeah.
That one. And but what's really interesting to me is recent research. Is as a result of the war in Ukraine, there was a satellites for Russia that was accessed by anonymous hacktivist types. Also Wagner, when the rebellion with Wagner, they had hackers apparently was published out on Twitter that were actually broke into ground stations in both hacktivists and people associated with Wagner were able to break into like Roscosmos, cloud data centers in the Russia, and were able to access satellites. So there's been more recent events where satellites have been accessed as well. And also more recently, separately from all the activities that have been in the news with Ukraine, there was also a ground station in Brazil. And what always surprises me, because I've always heard in the critical infrastructure that I always had the perception that industrial control systems, SCADA systems, space systems were air-gapped, where they were not connected to the internet. But it's been more and more proven, like in the cases here recently with the hacks against Roscosmos and other data centers, cloud-based data centers in Russia. But also in Brazil, there was a ground station just a couple years ago that was hacked. And the gentleman, the hacker, came in through the internet, exploited a web application, did SQL injection, and was able to get into the ground station and get access to I believe it's around 8 satellites, and they published on the dark web screenshots of at least 3 satellites that they had control of, and then there was a list of like 8 satellites that was possible. But the research that I saw. There was a source back to the dark web. The images showed 3 satellites that had been accessed via Brazil. So these are happening. Satellites are being exploited, but most of the time it's through a ground station. But there are speculations that some are coming up through unauthorized ground stations.
So one of the takeaways is that we should not only talk about software-defined satellites, more like a software-defined the whole space segment and also the ground segment.
That's right.
So the ground segment is an integral part, and that's often the attack vector actually goes to the ground segment, because
right.
You have people here, you have radios, you can do different kind of things.
So maybe what an underlying trend here is then using common computer chips, right? So Planet Lab has been using the Intel laptop processors from the start. Spire has been using Linux from the start. SpaceX Dragon uses like Chromium and JavaScript for the user interfaces. So with very common hardware, the same bugs are still there.
Is it the problem? Is it the problem? Because nowadays, I mean, we have probably converging to some kind of direction with the software. It's we have more and more software existing. We had a small satellite we built also. We just put like Raspberry Pi there. We would just put Linux there. Is it a problem for security if we define satellites with, let's say, commonly available software?
Dr. Greg Falco, who was associated with Johns Hopkins University in the U.S., he's now at Cornell University. He had a team do research where a common CubeSat operating system provided by NASA, they wrote a paper, I believe it's called, the name of the paper is WannaFly, and they went back and looked at a piece of malware and did some research to see if it was feasible to run some ransomware malware against the Linux satellite operating system that many people use on CubeSats. And they did not deploy the malware on the satellite operating system, but they did the feasibility study. And their research results were it's feasible that ransomware like WannaCry, and I think like I said, the paper's name WannaFly. So they looked at the WannaCry malware, and it's feasible that it could possibly be implemented to run on a satellite. So I wonder, at some point, at some point in the future, are we going to experience a ransomware attack against a satellite constellation because of the common operating system platform? Because everything is moving to Linux, and like Erik said, the common chipsets.
I think for now what helps is having the radio link. So the radio link is almost like a firewall that a satellite, at least not yet, it's not an IP on the internet. You can't like ping it freely. But in the future, they might be just part of.
Yeah, but there starts to be also the open networks like SatNox, for example. At the moment, it's just collecting the data in most cases. But what do you think? Would it be a problem if we start to have so powerful networks on the ground and maybe in the space as well, that most of the satellites are becoming nodes in a constantly upkept network?
Yep. I can see at some point that the proliferation of satellites, especially with CubeSats, becoming so much more economical and easier to get in, cheaper, more economical to build and more economical to launch for across industries and academia, that we could see that it takes on an Internet of Things personality and starts possibly getting accessible. And what's really interesting to me is as that happens and evolves, and those satellites they're adding propulsion capabilities. If a satellite gets hacked, what is the probability of a satellite with propulsion being able to be used to cause a collision with someone else's spacecraft or debris and create a chain reaction?
Yeah, so
a Kessler syndrome scenario.
This is definitely something. What do you think? What kind of like scenarios we might face? Like, Erik, you have anything?
No, I'm thinking that this might lead well into software-defined networks. So now we have mostly point-to-point communication, satellite to ground station, or maybe through relay satellites. But that's not how our internet works, right? They're routed where they can or where possible. So in the future, we can imagine that you don't know through which ground stations you're talking to your satellite. It's rerouted somewhere, and that makes it very difficult then.
And that's a really good point with the optical inter-satellite links and the interlinks of satellites and satellite to ground with optics, free space optics. That's going to make things more difficult. Because it's going to not, when we're not using RF, it's being more broadcast and more open. It's going to be more of a directed connection when it's a free space optics. That's going to help improve the security.
What kind of harm this can you imagine? I mean, you shared a paper where they have been studying how just simply manipulating the optical data of the fire detection satellite will already cause a lot of harm. How much this has been studied, that what kind of scenarios are even possible? So you can do I think ransomware is something like pretty, maybe even possible and probable in the future, because you don't yet, let's say, destroy anything, but you still get money.
Right.
And there's a sort of smaller threshold.
It's interesting you bring up the ransomware again. That reminds me, it's speculated that in 1999 timeframe in the UK they had a satellite constellation called Skynet, and I believe it's 3 or 4 satellites in that constellation, and during that time period there was a threat actor that proclaimed that they had control of that satellite, that they were going to hold it for ransom. Now, there's a lot of debate in the industry of whether anything happened or not. You can get into really heated conversations depending on who's in the room about what happened. But there is stuff published that during that time frame that there was hackers in the U.S. that basically told on the hacker in the UK who had gained control of that satellite. And at that time, there were people in a position of authority, according to the article, that said that they had access to the control channel of the satellite, and but they were able to knock them off. And then the gentleman that was believed to be responsible for that attack left for Japan to try to avoid prosecution by Scotland Yard that time. But like I said, there's a lot of controversy around that, whether what happened or not. But that was published in the 99 timeframe. So a satellite being held for ransom has happened before. At least speculate. There's something that happened in 1999.
Interesting.
So I just think it's going to be, eventually it's going to be a malware ransomware attack.
Yeah. So Erik, do you think that in the future then it's actually possible? Like I'm getting just an email or a message from somewhere that you cannot use your lawnmower because we have been blocking it by a hijacked satellite IoT network, and or even like all the lawnmowers in a city are starting to be behaving very strangely or attacking people or something like this. Would it be possible, some scenarios like this?
It's definitely possible. Probably not for you personally, but in a wider area, yes.
Yeah, because we're going to have also like a lot of ground assets are going to be in an IoT network all the time. Like everything is becoming the node of the network, including your car and the buses and everything, and satellites as well. So it's possibly a big problem when somebody is really getting into the system. I was also thinking during this conference here, how big threat you see when we need to build space traffic management system. I mean, like we just have so much traffic. At the same time, this is also enabling many attack vectors which are possibly influencing like very big amount of satellites at the same time. Sort of you are getting to this system and you're putting red lights to many different places and you're starting to see collisions. Is it
or
possible?
You fake a location of a satellite and then accidentally.
Right.
Right. So can we protect our satellites? Is there anybody working on this? Like, do we have any kind of work done with protecting of this, like through the software? So because most of the, or many of the attack vectors are somehow coming through the communication and software. Right. Is there anything happening in this front?
Well, as I started really digging into space security a few years ago, I was amazed to learn, because I assumed, similarly to assuming that there was air gaps between the ground stations and the internet. There is in some cases, but there isn't in many cases, because it's on the internet that they're not. But also assumed that everything was encrypted, which I was very wrong. Some satellite communications are encrypted, a great deal are not encrypted. But fast forward, I have been encouraged, the European Space Agency has a satellite that, as Erik mentioned earlier, about the software-defined radio, the satellite being able to protect itself. The European Space Agency has a satellite up now, it's been in orbit for a few years, that if it detects intentional or unintentional interference, the software-defined radio can reconfigure itself to react to that threat actor. There's an organization in the U.S. called Aerospace Corporation, known for doing a great deal of aerospace research and solving really hard problems in the industry. They have a satellite that is using, from what I've read, I think it's called Slingshot, and it's using technology, architecture that came out in in the early 2000s when Cisco came out with the concept of self-defending network, where intrusion detection system could detect behavior, a signature, looking at statistical data, could determine there's an attack, and then it could reconfigure the firewall or routers to protect themselves against that threat actor. Well, that same concept now is Aerospace Corporation has on a satellite in orbit, so that if that satellite is determined that somebody's trying to send commands to it, somebody's trying to change the configuration, the satellite can reconfigure itself so it can somewhat defend itself. So the European Union, European Space Agency, has the satellites doing the RF automated defense. In the U.S., they're doing the more traditional network defense, where the satellites. But where I see is what we've been talking about and what I'm researching. If we can use cloud-based technologies on the satellite, containers and things, and we've proven, the European Space Agency's proven that RF self-defense works in space. Aerospace Corporation has proven that the network automated defense can work in space. Why can't we combine that with containers, whether Kubernetes or Docker, and make the satellite so that it can dynamically morph and defend itself? If you detect a threat actor in one of your containers, you can just go change it and maybe pull back a gold image, a trusted gold image container, and either remove the container that is suspect, compromised, or maybe we move it off. It's like Erik mentioned, a software-defined network on the satellite. Maybe we could go and move that container that is that we're uncertain about, that's acting suspicious, move it off to a different network on the satellite and monitor it and gain intelligence and monitor and see what the threat actor is trying to do with it. There's a concept goes back probably over 14 years that called a moving target. In academia, I believe they called it the papers I read called it a moving target. So maybe we could move to a moving target defense with the satellites. It's a good area to go and research.
Now, I know you have been publishing for ideas about, for example, how satellites could self-monitor themselves, like assimilating all the data from different sensors and physics, and then recognizing patterns, and then satellites can diagnose also themselves. Maybe something they should do in the future.
Yeah. With what we have with artificial intelligence and machine learning, I'm thinking that we ought to be able to go and collect both the physics-based sensor data, combine that with the TT&C data, the commands, all the network telemetry data, of who the satellite is talking to, who's trying to talk to the satellite. Take all of that data, but take the TT&C data along with physics-based data, the power, the timing, the navigation, the star seeker sensors. Take everything that we can pull data from and correlate that together and use machine learning and try to better predict is someone trying to manipulate our satellite, or we can forecast a issue with the satellite. But when we start doing all this machine learning on the spacecraft, we have to also know that the adversaries are going to go after that machine learning model as well. So we're going to have to train that machine learning model to defend itself, because there's adversarial machine learning where the adversary is going to try to manipulate the data and throw us off the track. So we're going to have to use counter-adversarial machine learning to train the model to expect someone to try to influence that model so that the satellite can defend itself. And so maybe we could go long-term, we could go to a model of an autonomous satellite that can defend itself with minimum operations.
Erik, I have a question for you as well. So you have been working with the new space companies and seeing a little bit of new space during your career. So how do you think these kind of models and ways of working in a new space company, let's say agile way of making software and all this, is it really suitable for the future and protecting the satellites, or should we change something, or how it works?
Yes, I think it is, and I think it works both ways. So it can be more risky, but you can also fix problems much more faster.
And can you, for example, is it a good thing or bad thing to use open source, for example, code in your satellite?
I would say yes. It saves you development time. And if there are any security issues, we should fix them anyway.
So it's going to be also, let's say, a cloud of problems, which a big cloud of hackers are either exploiting or fixing the problems.
Yes. But on that, what we have maybe seen more with new space is this edge computing. So there are maybe even a couple of dozen of startups who are working on this kind of separate processing board or computing unit. So let's say you might want to keep your onboard computer simple and cheaper, but then have this high power board subsystem next to it. These are often the same NVIDIA chips that we use to learn machine learning models, to train them. And these are probably also the computers where we would run those apps, container style, offset style. So I think that's one of the hottest topic in new space.
Yeah, this is also bringing us, I think, to the future. Let's talk about the future, what future might come. So it seems like there's a lot of more and more networks. Like satellites are going to connect to each other and networking more and more with the ground, with each other, with like different layer of geostationary satellites, rely on the navigation signal from the other satellites. Paul, you have an extensive experience on networks. Is network a more vulnerable creation, or do we have a new level of threats when we start to have really big networks?
I'm really interested to see how the network telecommunications in space is going to evolve with free space optics, being able to have interconnected satellite constellations for like global internet, and we're moving to 5G, 6G in space, of how those communications, what the attack surfaces are going to open up, because now the satellites are going to be a part of not only private networks, but when we start adding 5G, 6G, and our phones are communicating to the satellite, now we're opening up a new attack surface where everyone has data communications to the satellite. And we're human, and humans make mistakes.
Yeah,
Erik.
It's interesting that one hand we have these developments in edge computing to like reduce the data we downlink, but then we also have orbital data relays that are coming to enable much more data downlink. They can also be optical, so two almost conflicting trends. And
we were having very fascinating conversations just before the panel about that cloud is moving to space.
That's right.
So edge computing in space is going to be more and more a thing. Power is cheap in space. You don't have also maybe like overheating problems and other problems, easier to manage. So we have a lot of data in space probably in the future. We might have also a lot of like AI processing capabilities in space in the future. So Erik, what do you think? Do we have an AI in the cloud in future around the Earth
we
on orbit?
already have. So HP launched a space-borne computer to the ISS. So that it's basically a regular server with like 100 terabytes of SSDs, but only modified to work with the cooling systems of the space station. But it is a regular computer, and you can running Windows or Linux, and you can use the same algorithms.
We were also talking we're thinking if there is illegal material in this cloud in space, what happens next?
Yeah, I think one problem that I've been thinking about is when I started reading about how edge computing is moving to space, what used to be called fog computing, I couldn't help but, being a cybersecurity professional, I couldn't help but think, how are we going to execute forensics against the cloud technologies, the storage, when it gets in space? Because if we put data and information of economic value in space, criminals are going to follow. They're going to follow the financial opportunities. If we're there, for benefit of mankind, benefit of financial opportunities, like image processing, et cetera. The criminals are going to follow. And so how are we going to conduct forensics and incident response and collect data that is going to be acceptable in the court of law around the world, whether you're in the US, we're here in Europe, different countries in Europe, and who is going to be responsible for collecting that and establishing the standards? Is it going to be the ITU, Interpol, IEEE, coming up with these standards of how we go and collect forensics data? Because I don't believe we're going to probably send an astronaut to pull the hard drive of a satellite. And something that along these lines that I found very interesting research in this domain is that they're actually talking about putting data centers on the moon. Apparently there are lava tunnels on the moon that go down vertically and also then horizontal. And I have seen lava tunnels on the Big Island in Hawaii, which were amazing, but I had no idea that there was such thing as lava tunnels on the moon, but it is. And there's a company out of the US, or maybe other companies, but there's a company in the US called Lone Star, and their business model is to go down into like a vertical lava tunnel and then go horizontal and put data centers on the moon. And if they put it in that lava tunnel, it's going to protect it from the radiation of the solar system and all of the hostile environment in space. But are we going to see it? But if there's if the terrorists, that the criminals follow our data to the moon, how are we going to do forensics against that? Because the criminals are going to follow. There's going to be a terrorist and be able to get the data that is going to be legally required and follow the processes that attorneys, the court of law is going to respect and appreciate. I don't know. I think it's a really interesting world where we're headed.
Erik.
But before we build data centers on the moon, I think we will build them in orbit. So, for example, Lumen Orbit, the recent company in the Y Combinator batch, they just raised about 10 million, and they really want to build big data centers, bigger than the International Space Station. And I think it's an interesting business model because computing is a big business on Earth. So if we can do it cheaper, better in space, it could be an immediate revenue source. But I think there is a lot to figure out in terms of whether you can actually make the unit economics work, and cooling is difficult in space, and maintenance is even more difficult. So not sure what will happen, but it's an interesting path to explore.
But destroying the data after the usage is not necessarily so difficult. You just like drive the satellite down, you burn in the atmosphere, isn't it?
Maybe, yes.
What do you think, like, if we get...
But we don't want to really burn it up.
Yeah, I know you also brought it up here before that the energy production in space and transferring to the ground, would it be even necessary to transfer it to the ground if we have all this like energy-intensive data mining happening in space? What do you think?
Maybe. So we'll still need energy on Earth, but yeah, I'm uncertain when data centers in space will become like a viable business models. They have other challenges than pure energy has, and I don't think anyone has figured them out yet.
All right, we are on the edge of our time window almost, so I'm giving you, before I go to the questions, I'm giving you the opportunity to propose what should be the topic of the next conference next year. Paul.
Well, the first day of the conference had a lot of conversation about the law and policy. And the question I have, my background is purely technology and cybersecurity. But the question I have for attorneys is, if there's an incident in space where a cyber attack takes control of spacecraft, space assets, and so a spacecraft collides with another spacecraft because as a result of a cyber attack, who's going to pay the cyber insurance or the space insurance? And should companies who own spacecraft, should they have cyber insurance on the spacecraft as well as space insurance? I think, and going back to your conversation earlier, you brought up with Erik about IoT devices. I think we had the conversation at the break. What with IoT integrating with satellites and the devices on the ground, say cars that are self-navigated, and the car is communicating to the satellite, like with 5G and 6G communications. What if someone hacks the satellite, and the communications is being used to talk to the car, to navigate the car, self-driving, and the spacecraft, under the influence of a cyber attack, causes a car to crash? Is it the car insurance, cyber insurance, or space insurance? Because I can tell you, I'm going to sue everybody if it's me.
So I think this is.
So who's going to pay?
Yeah, and the next thing it seems like we should start to educate space lawyers so for all these areas. But Erik, what is your take for the next year conference topics?
I would like to maybe see more people who have actually written software running on satellites. So maybe the onboard software providers.
So that means like actually maybe even a show here. We have a couple of hardware pieces which are running the software, and the hackers then like hacking the software.
And I also like the question, so I will
okay.
re-answer that.
So thank you very much for this conversation. What was absolutely wonderful. Now you can submit some questions to the Mentimeter. And we'll start with the first one. So, will software-defined satellites enable real-time gaming in space? So, what do you think? My question is, who is going to play a game there? But yes, real-time gaming in space.
One of my simple dreams is just to drive a rover on the moon. Like, see the video, just have a joystick or mouse and just drive it on the moon. Doesn't have to be long, but it seems such a fun thing to do. So, that would have to be largely software-defined, clearly.
Paul, what is your take?
I haven't put a lot of thought into that yet.
So yeah, I have been thinking like might be even like this real-time gaming, maybe the gaming on the ground will replace some of the exploration. I mean, like if I can be on Saturn moon in the morning and on Mars virtually in the evening, do I need to take the hurdle of going through the whole like long trip to Mars? Maybe I'm not going to want to go to Mars anymore at all. I'm just gaming. All right, but let's take the next question. So, personality of the satellite. Do software-defined satellites have feelings and emotions? A good question, a good question. So, who's going to answer?
Well, when I brought up, when I used the term personality, what I was referring to is the technical capabilities of a configuration of the satellite. So you could change containers. One container might be focused on image processing from, say, maybe mapping, and then you could change the configuration, which is what I refer to as the personality, to some kind of Earth observation. Maybe it's monitoring climate change. Maybe it's monitoring weather. And that's so when I talk about personality, that's what I'm talking about. Maybe mapping, maybe Earth observation, wildfires, weather, climate change, things like that.
Erik, any take on that?
Most of the satellites are built to have personalities. They have their own quirks, but they are not smart enough to be sentient.
Yeah, this is an interesting question, actually. I have to give my comment as well. I was reading a paper which was going through different big AI language models. And in order to, we like human, to deal with this kind of thing, and even to make a mental image, what it does and how we should like act with this kind of player, the word personality was the most useful. So you are just interacting with this model, you make the feeling what kind of personalities this model have, and then you have a tool to work with it. So it's not necessarily a totally useless term. Let's take the next one. How communicating differences, atmosphere and so on surface of celestial will impact space missions? Anybody helps me to actually translate?
It's a new business model, right? So
Okay.
data relay satellites for the moon. ESA has their own mission being planned. Again, that's that's this more point-to-point to internet-style communications that you want to be able to communicate through different other objects on the moon if your rover can't directly talk to Earth.
Yeah, I've been reading where they're architecting a 4G network on the moon now. My initial thought with the effects of the atmosphere, that's the effects of being in space. And the further we go out, we have less protection in our atmosphere. That's the reason a lot of spacecraft do not have encryption, because of the effects of being in space, because of radiation and the particles, the galactic particles, like the ions being spewed out from the sun, can cause bit flips on spacecraft that are not radiation hardened. So if we start putting communications equipment, say on the moon, on Mars, things like that, it doesn't have. It's going to be more exposed to that hostile environment of space, and so the equipment's going to need to be radiation hardened to a greater degree to be able to maintain communication and secure communication.
Okay, so the clock is winking and telling me like, yeah, we are reached our time limit. So gentlemen, Paul, Erik, thank you very much. It was extremely pleasant 45 minutes on the stage with you. I learned a lot. I hope all audience learned also something, and thank you very much, and thank you for the wonderful conference.